The next concept we will introduce here is irreversible and reversible processes. Let's start from the irreversible processes. What is an irreversible process? The definition is if the system and all parts of its surroundings cannot exactly be restored to their respective initial states. After process has occurred. If your system and the surroundings cannot go back to the initial state, then this process is called an irreversible process. We can think of a few examples. First one, heat transfer. Heat transfer is irreversible. It's very straightforward. So for example, you have a cup of hot coffee and you leave it on your desk. Over time, heat will be transferred from the hot coffee to the cold environment, and this process is not reversible. You cannot tell the air to give you back the heat and deliver it back to the hot coffee. So this process is not reversible. We call it irreversible process. And then the second example we can think of is friction. Friction is also irreversible. You can think of your car. You're driving on a freeway and then suddenly you have to brake. What is going to happen is the friction between the tire and the freeway will slow you down. So the kinetic energy becomes smaller and it will become heat in the tire. So your tire will become hot because of the friction. And now the energy is converted from kinetic energy to internal energy of the tire. And this process is irreversible because you cannot ask a tire and say, hey, cool down and give me back the energy so I can drive my car. It doesn't happen. So this process is also irreversible. Next, we talk about reversible processes. What is a reversible process? The definition is if both the system and the surroundings can be returned to their initial states. And then you can call this process reversible. It is purely hypothetical. All actual processes are irreversible. Everything in our life is irreversible. For example, getting older. However, some of them can be approximately reversible. Next, we can think of two examples for reversible processes. The first example is a pendulum. It's going back and forth. So now if you put a pendulum in an evacuated space, meaning there's no air, so there's no friction. If there's no friction between the pendulum and the air, then the pendulum can go on forever. It can always be returned to their initial state. This is an example for a reversible process, and we know in reality it will never happen because in reality you will always have air, and air will cause friction. Friction is not reversible. Okay, another example we can think of is you have a cylinder and a piston, like a simplified version of the engine. What's inside is the gas. What is outside is the atmosphere. If we slowly increase the pressure of the atmosphere, then the piston will be pushed to the left slowly. And then we decrease the pressure of the atmosphere again slowly. So the piston will be pushed to the right slowly, and then it will be restored to the initial state. Those are the two examples for reversible processes, and keep that in mind. It is purely hypothetical, but some of them can be approximately considered reversible. So now we go to the approximation. What is approximation? It's called internally reversible. That's a compromise we take. What is the definition of internally reversible process? The definition is one for which there are no irreversibilities within the system. Irreversibilities may be located within the surroundings. Here, let's give you one example. So here we have a pipe, And what's flowing inside the pipe is hot steam. So this is a control volume. The steam cools down at a constant pressure through a tube. It's flowing from left to the right. If we say we do not consider heat transfer, there's no heat transfer from the hot steam to the cold environment. If there's no heat transfer, there's no irreversibility, and then the whole thing must be reversible. And we know in reality you will always have heat transfer. The hot steam has to lose some heat to the cold environment. So next case, what if you do have heat transfer? What if you do have heat transfer? Then this process will be obviously irreversible because heat transfer is irreversible. However, the only irreversibility we have, which is heat transfer, happens on the boundary, on the dash line. It doesn't happen within the control volume. And then if that's the case, we can call it internally reversible. Because the irreversibilities only happen on the boundary. It doesn't happen within my control volume. That's why we can call it internally reversible.